Next, put a little vinegar and water together and then pour in the extract. You get a nice red color. How about some washing soda and water? Turns green. And finally, some lye and water.
Good day, grade 9 science students. All the examples that you just saw were examples of chemicals changes. Why were they not physical changes? Well, we're going to talk about why that was. How do you recognize the difference between a physical and chemical change? Well, if we look at this, this is another example of a chemical change. When you crack one of these cold pads, they release coolness, and that coolness is an example of a chemical change. So let's talk about what physical and chemical changes are. A physical change is a change where the chemical makeup of the matter does not change. It remains the same. So anytime that, for example, water was going to do a change, if it's still water molecules, then it is a chemical. It is not a chemical change, it's a physical change. If I take a piece of paper like this right here, and I rip it in half, that is still paper. It's now two pieces. It is a physical change, not a chemical change. If I lit this paper on fire, though, that would be a chemical change. So, the matter may change state or form, but it's still the same type of matter. If you take water and go from a liquid to a gas, so you heat it up and you boil it, it is still a physical change because it's still water. So condensation, sublimation, suspension in a liquid means you're dissolving something in a liquid. You have evaporation, crystallization, or you form a solution, sugar and water. It is not a chemical change, it is a physical change because the chemicals are mixing together. They are not actually changing, or they're just changing state. Okay, so here we have two examples of a physical change. You have a piece of metal over here in the corner right by my face, which is being melted. And that's just a change of state, so that's a physical change. This rock is just being busted into smaller pieces, so that's also a physical change. Nothing new is being formed there. And similarly, if you just took a piece of wood and chopped it in half, that is a physical change because you are not creating anything different than wood. It's just wood in smaller pieces. So chemical changes, you actually have to change the chemicals. And it does change, so the chemical makeup does change. You cannot change the matter back to what it started with. So for example, if I burn a piece of wood, I can't take that gas and the ashes and turn it back to a piece of wood, okay, to what it started at. So new substances form when two other substances react. And how do we know if a chemical change has happened? Well, we have a change in temperature. This is one hint that we're forming something new. So in an ice pack, you had a chemical change because it got cool. So you know you have your chemical change. Another reason that we know we have a chemical change is we form a precipitate. This was the example that I started the video with. You form a solid when two liquids come together. And it actually can be quite beautiful. And you know that it's a chemical change because you have this solid being formed. Or if you have a gas being formed, we know that's a chemical reaction. Or you have a heat or light being formed. If you hear a pop, that means gas is being formed. So if it gets really hot or cold during a reaction, you know something happened, or especially if you form light. So this is a piece of magnesium here by my face right above me, looking up above me, and over here on my over here you see that light being formed. You know it's a chemical reaction because you're forming that light. Okay. Or you have a color change in general. So you had two chemicals together and you form a different color. For example, in the far beaker over here, Erlenmeyer flask being poured into another, you have a color change. Two test tubes being added together, you form a color change. That is an example of a chemical reaction or chemical change. So how do you know a chemical reaction is happening? Is odor could be created, and whenever we have an odor or a smell in a lab, we want to make sure that we point the test tube away and we waft with our hand, which is like this. You're wafting and you're not smelling directly the chemicals because they can be dangerous. Yeah. So another form of chemical change is corrosion, and the chemical reaction between a metal normally and its environment causes it to deteriorate or break down. That's what's happening to my car right now. I need a new car. It's rusting. It's corroding. And this is also known as oxidation or rusting, okay, when oxygen reacts with iron. And and when your car starts to rust, it can rust all the way through. So one way that we can prevent corrosion is by painting the surface of the metal. So if you scratch your car, one of the things you want to do is get some touch-up paint and immediately paint it, because if you scratch it down to the metal, that metal will start to corrode, oxidize, and rust, and will eat away at it. One thing that people do with boats is they actually add a zinc plate, and a zinc plate will actually prevent corrosion from happening. You learn when you take more chemistry, you learn why that is. Another type of chemical change is combustion. In combustion, all it is it's the burning of something to produce energy. And normally you need two things to make a combustion reaction happen. The first thing that you need is a fuel. And then the second thing you need is oxygen or an oxidizer. So fuel and an oxygen will produce heat. Now, to get it going, you need a little bit of heat as well. But anytime you burn, like for example, if you wanted to burn a log for a fire, you need a little bit of heat to get that burning going, but then it releases a lot more heat. Okay? So in summary, we can say a chemical change is producing a new chemical product. And there's 5 things that we need to know or remember for us to know that it's a chemical change. And I'm going to give you one moment. So these are the signs of a chemical change. The first one is going to be heat or light. If you see heat or light, then you know you have a chemical change. If you see a color change as well, you are going to know that you have a chemical change. 3, if you have a precipitate form or a solid, you'll know you have a chemical change. If you produce gas, so gas is being produced, you know you have a chemical change. And the last one, number 5, is that it's irreversible. And that means that you can't get the original things that you started with back. So that's it. So let's just do a quick test here. Is this a physical or a chemical change? So we got roasting of a marshmallow. Is that physical or chemical? You said chemical, you're correct, because there's heat or being involved here. There's fire being involved. It's a chemical change. Ripping a piece of paper, that's physical. Crushing a can, physical. Rusting of a nail, chemical, because that has a color change. Banana rotting, that is a chemical change because it is a color change, and you can see it actually produces odors as well if you leave it long enough. Again, lighting a match, fire, that is a chemical change. And finally, taking ice and turning it into water and then finally into a gas. That, believe it or not, ladies and gentlemen, is a physical change because it is still water that's there. You don't have a new chemical being formed. And that's it for today. We'll practice this more tomorrow. Thanks for listening.